Hello and welcome. This is Y 2025. You're in Hall Brachium. And if you're looking for the Pinball Wizard talk, where we're talking about building an old pinball machine, you're in the wrong tent. This is about an open source Flipper module for Wi-Fi pen testing and ethical hacking. So please welcome for the Flipper Blackhat, Ryan.
Hey guys. Has anybody heard of this before? Like, just raise your hands. Some people? Okay, a few people. Cool. Just wondering. Yeah, so I'll do a quick introduction of myself. Oh, there's a weird little bar at the bottom. Sorry, one sec. We'll do it this way. Slideshow. All right, that's better. So that's me. Rootkit Labs is my company. We make open source stuff with open source stuff, mainly security, but some other stuff. There's a QR code you can scan that goes to all my stuff, socials and whatnot. Okay, so why did I develop this thing? We'll go right into the purpose of it. So I bought a Flipper, and I thought it was a cool device. And being someone that makes hardware, I created a Reddit thread. Okay, just basically asking people what they wanted, like what would be something cool. And this person here, around 2 years ago, replied that they wanted a Wi-Fi board that does the current evil portal attack, but also sends users to the internet. So people that don't necessarily know what the evil portal attack is, it like puts up a splash screen, users enter their credentials, and then you can grab them. So this is for ethical purposes only, by the way. I should have mentioned that at the beginning. And there are current devices to do stuff like that, and they all use the ESP32. So forwarding people through to the internet, having two connections, one on the ESP32, one AP, and then one also connected to the internet, and forwarding the data through would probably be quite a bit of work. So, okay, are we actually going to put a Linux-enabled SoC on top of a Flipper Zero? Yeah, why not? So we'll just use a Raspberry Pi. No, let's make our own SBC from scratch. So that's what we did. So I picked the Allwinner A33. So this is a quad-core ARM Cortex-A7 microprocessor. It is something similar to like what you would find on a Raspberry Pi, but a little bit better as far as power consumption goes, and also not as powerful. But yeah, it's the block diagram for the part. Yeah, so more of kind of what I just said. So the reason why I picked this part is it's a little bit long in the tooth. It's about 10 years old now, but the power consumption is nice. So it's a sub-watt part, so less than 200 milliamps from the 5-volt bus, which is nice. And it has a 0.8 millimeter ball pitch, so that's the distance between the pins on a BGA package. And this is nice because you can hand solder this, where a 0.65 gets considerably more challenging, and then you also have to have HDI, like micro vias and different things like this, so your PCB cost gets quite a bit higher. And I also used this in another project a while back. Yeah, so I could recycle the engineering for this guy. Cool, so I'm just going to go through like the schematic and how I designed it. So the A33 wants 5 power rails, 3.3 volt, 3 volt, 2.5, 1.35, and 1.1. And they all have to come up in a specific sequence. So I picked this TI TPS 6209 buck regulator, and this basically took the 5 volts from the Flipper Zero and converted this all into the required rails for the part. So yeah, and then this SS pin can be used to sequence all the rails in a certain way, because when you deal with microprocessors like this, you can't just slam all the rails on at the same time. They won't work, so you have to sequence them very specially. So you can just use a small capacitor with this power supply, and this worked quite well. Okay, so the first radio, so the idea was to have 3 radios on this thing, 3 Wi-Fi radios. And for the first Wi-Fi radio, I picked an RTL the 8723DS, where the S stands for SDIO. So this is a module that's connected to the Allwinner A33 over an SDIO bus, which is similar to like what a SD card uses. Yeah, and it also has Bluetooth as well, which is connected over a UART bus. And then as far as the second and third radio, the idea was to just expose USB-A ports so you could plug in whatever you wanted. So I typically, when I send the device to people, I typically include an RTL 8821C, CU, where the U is for USB. And this can be, this has mainline Linux kernel support for, I think, a few years now, which is nice. Because I know the out-of-tree Linux kernel modules for Realtek parts can be a little bit not very nice. And then it's a 2.4/5 gigahertz radio as well. So you can have, in total, 3 radios for all sorts of stuff. Yeah, so the USB-C port on the side of it. This is for communicating to the main chip over UART for initial bring up. And UART is also the main communication method from the Flipper Zero itself. So, and I wanted to use the same bus, so I actually ORed the signaling together. So you can either use the UART from the Flipper Zero or from the USB-C port on the side. So one or the other, but not at the same time. And this worked pretty well. And I used a CH340 chip, which is like a USB to serial adapter. And that worked pretty well as well. So there's a DSI bus on the Allwinner A33, and I never intended that people would be interested in using it, but I put down a connector anyways because it was not expensive. So for those of you who don't know, MIPI DSI is a bus protocol that's used quite a bit in, I'd say, cell phones to communicate with display. So it's sort of display serial interface. And then there's also a backlight driver there. So this is a boost mode backlight driver because I think there's like 12 LEDs in series for the backlight. So it needs like 12 volts or something like this. Yeah, so if anyone is familiar with high-speed design, so it was DDR3L RAM. So KiCad has quite a nice length matching tool, which has existed, I think, since version 8. And I mean, it's just incredible that we have open source software that can do this now. So, yeah. But yeah, and I should probably explain what length matching is. So when you have a high-speed parallel bus that operates very fast, you want to make sure that when the Allwinner puts data on the bus, all the bits basically hit the input pins of the RAM at the same time. And the way that you do this is changing the length of the traces so that they're all the same length. They're all the same length, you get the data at the same time, everybody's happy, it boots. So the layout for the supplies, you also have to be quite careful with switch mode power supplies. But can I point? I can point, cool. So the thing that you have to be careful with these is to keep your hot loop as short as possible. So this is basically the output pin, which is going to be switching, like a square wave, and then it goes through an inductor, and that smooths it out into whatever voltage you want. So for instance, this supply is taking in 5 volts, and it's making 1.1 volts. And that distance from the output pins through the inductor, through these bulk capacitors, through ground, and then back through the chip should be kept as small as possible. So a little tidbit of information if you ever want to lay out switch mode power supplies. Also, you can just look in the data sheet. It gives you the exact layout to do. But yeah, so I got away with a 4-layer board for the SoC. That's fun because it's cheaper and I don't know, it's just fun. And I probably wouldn't, so I probably would not have been able to get away with this if I used a 0.65 millimeter pitch BGA package, but, or if I use more GPIO. So a lot of the GPIOs you can see here are left unconnected. The main thing I was just using this chip for were the cores and USB. That's pretty much it. And then all the support stuff you need to get it to boot. And no micro vias. So if you don't know what those are like very small vias. And if you don't know what vias are, those are those little holes all over the board that connect signaling to different layers. Yeah, so power distribution. This was my power plane, so you can see there's a ground, 3.3 volt rails, 3 volts, 5 volts, and 1.35 volts. Yeah, and the reason why these traces for power are kept quite large is because you can have quite a lot of current flowing through them. Yeah. Okay, so assembly. So this isn't the Flipper Blackhat. This was another project I worked on before, but it's very similar. It uses an A33, same power supply, same everything. Anyway, so I put this in just because I want to show that it's possible to hand assemble these boards yourself. I think there's quite a few people in the community that might think that working with BGA components is very challenging. It's honestly easier than like TQFP, like the ones with the pins all on the outside. Yeah, like 0.8 millimeters, this pitch is okay. And I think I built up like 10 of these boards and all of them worked. Yeah, so these are, again, different board, but for all intents and purposes, yeah. Okay, so for the Flipper Blackhats, I just paid someone to do the PCBA. And this was because, again, I had this previous design from a previous project, and I kind of knew that stuff was going to come out pretty quickly, and it should just work. So there's a picture of the device, and with the specs next to it. So yeah, it's an all-winner. I've already talked about this. Quad-core, 1.5 gigahertz, 512 megabytes of RAM, and then there's the one inbuilt radio on the back that you can't see, and then two USB, and then USB-C on the left for UART. And that little FFC connector on the far right is for a MIPI DSI screen. And it's black in the shape of a hat, which I thought was pretty on the nose. Yeah, so that was kind of all the hardware. And then it was received quite well by the community. This was pretty exciting for me. A lot of the stuff that I do, I try to make, like, I don't necessarily do things personally just for me that I think is fun when I build stuff like this. Not to say there's anything wrong with doing that, but for me, I like other people in the community being excited about something, wanting to help out. And for me, this signaling on whatever social media really encourages me to continue building all this open source hardware. And without that, there have been projects where I posted and no one really cares, so I kind of just give up. But yeah. Okay, yeah, so some people like it. Let's keep going. Software, so getting it to boot. Are there any Linux users here? Oh, okay, that's expected, but awesome. Cool. Okay, so so Linux is a kernel, and you need a bunch of other things to get a full working OS to boot. Let's check time. So there's a few different. Okay, yeah. So for ARM, Allwinner provides a binary blob called boot0, which is basically the very first thing that happens on a chip like this is there's an internal bootloader in ROM. And nothing has been initialized. The only thing this internal bootloader does is reach into the SD card and grab a file called an SPL, chuck that into its internal RAM inside of the chip, and then that program initializes the RAM. So that's like the first bootloader. And Allwinner provided a binary, and a bunch of awesome people, which I'll get to later, reverse engineered it and merged that into U-boot. So U-boot can build you something called an SPL, secondary program loader. And so once you have the first internal bootloader, that grabs the SPL bootloader, that initializes the RAM, then that grabs U-boot, which is, I guess, the third bootloader, and that puts that into the RAM, fires. U-boot is like file system aware and has like a whole bunch of other like really nice things that you can do with it. But I mean, the thing is, it's a bootloader, so what U-boot's going to do is it's going to grab your kernel, shove that into RAM, and then you're going to run. And then you're going to boot, and then you need all your user space applications. Ah, cool. Okay, I need to go faster. Explaining bootloaders forever. So Buildroot is a really nice project for building images. So what this does is basically all that stuff, you give it a configuration, you give it device tree, and it'll just make you an image, and you flash it to an SD card, and boom, you can just boot. Okay, I'm going to skip that, actually, because I'm running a bit low on time. Okay, so there's some limitations of Buildroot. So Buildroot is extremely good at building bootable images, but it isn't really for building distributions. Because the main reason why I say that is because it doesn't build binary packages. So integrating a package manager into Buildroot is kind of challenging. So I'm potentially might be moving to RMBN or something else. Oh yeah, so Linux Sunc community, I just wanted to mention them. So these are a bunch of people that work really hard to merge Allwinner code into Linux. So because of these people, the Flipper Blackhat can run Linux version 6.15, which is like the newest thing, because it's all mainline stuff, and there's very little out-of-tree patches and code that have to be pulled in. Yeah, so thank you to these guys. Okay, so yeah, I guess getting into the weeds a little bit. Is anybody familiar with device tree? Oh, okay, cool, nice. So yeah, device tree is a way, so yeah, Linux will take a device tree file, and your device tree file basically describes how the hardware is hooked up. So this is the device tree block for my MMC1 bus. So this is a SDIO bus, and this is the one that connects to the Realtek Wi-Fi chip. Yeah, so this is basically telling you it's nested in a way that this is descriptive of what driver it needs and how things are hooked up. So basically, to get the Wi-Fi chip to work, all I need to do is put this into the device tree and yeah, enable it in kconfig, and you're just going to have a working Wi-Fi module, which is pretty cool. Oh yeah, okay. Yeah, my screen is rotated, so I got the screen working. I'll get to that later, but if anybody knows how to rotate it at like the kernel level, that would be amazing, because this little rotation thing here doesn't work. But yeah, anyways, maybe talk to me after. I could always. Oh yeah, it also runs Doom, which is super fun. That's always good for a laugh. Okay, so software that I've created for it. So I've created the Blackhat app, which is it's a pretty straightforward, it's a giant bash script basically, and it has like these simple commands where you can run certain exploits and different things like this. So one is like Wi-Fi connect, and it'll just connect to Wi-Fi. And the idea is you can like drive this manually through SSH or the serial port, but the idea is the Flipper actually should send UART to the Blackhat to drive these things. So the commands are kind of kept short, and yeah, more on that later. Okay, yeah, so more on that now. Yeah, so the Flipper is connected to the Blackhat. It obviously powers it, and then there's a UART bus that it sends commands to. Flipper app, yeah, so I created a Flipper app which is merged into the Momentum firmware. So if you run Momentum, you should just have this app already. And this is basically used to control the Blackhat. Yeah, a few different kind of niceties. When you flash the OS to the SD card, if you put this then into your computer, you'll see there's a FAT32 64 megabyte partition on there with config files. You can change the kernel command line arguments. You can do, like Raspberry Pi does this as well, so I kind of just took this one out of their book. But yeah, there's a blackhat.config where you can edit that file and have various configurations. And this seems to be working pretty well so far. People are pretty happy with this. So one of the one of the nice things that really separates this from like some of the other add-on boards is we can run Python, like full Python. So we can install all sorts of different Python packages, like pip is on the device. And then there's a folder in this FAT32 partition I was talking about called scripts. So, oh, only 5 minutes. OK, so you can just dump scripts in there. And then through the Blackhat, you can basically run these scripts. So actually, I think 5 minutes should be OK. So like one of the possible use cases of this is let's just say rat driving, not rat driving. So this would be similar to war driving, where you're scanning for open APs, you're connecting to them, you're then doing an Nmap scan on the network, and then you can do a vulnerability scan on each device. So if anyone's familiar with a project called Routersploit, it's a exploitation framework for embedded devices. Like lots of routers are on there, IP cameras, basically like all sorts of like insecure, like cheap IoT things that are insecure. And then the idea is you could actually like obtain a reverse shell to this, deploy a rat which can connect to a C2 server. So everything in this presentation is for education, entertainment, and ethical purposes only. But yeah, so this is what no but. I haven't been to jail, but I don't think it's fun. Okay, so yeah, what's next? So what's in the rest of the book? Okay. So what am I working on now? So like I have most of the stuff I've talked to you about is kind of working. So I really want to, I'm working on a C2 framework. So, okay, if you don't know what C2 is, it's like command and control. So this would be like if you deploy a remote access Trojan, it would phone home to a C2 server. So I'm going to write my own C2 server, so that will be open source as well as a rat written in C. Yeah, so stay tuned for that on the software side. So there's been a few community developed cases. I'm not really good at mechanical engineering stuff, so I kind of just built the board, and everyone told me that it needed a case for like a year, and I'm like, yeah, I'm waiting for someone to make it. So yeah, this person, Tron Cases, made a pretty cool case, and this integrates the screen as well, which I guess you guys can't really see that very well, but there's a picture of it. And then, yeah, another friend of mine created kind of, this one is quite a bit smaller, so the idea is this one you would probably not use with the screen, or you could like double-side sticky tape a screen to the front of it. And then, yeah, this one's a bit larger. So, anyways, I just figured I'd give them a shout out because it's cool stuff. Final remarks. Yeah, so I think I kind of achieved my goal, and the scope has grown so much beyond this evil portal internet redirection thing. Yeah. Demo time, pretty much guaranteed not working. Oh. How much time do I have left? 2 minutes. 2 minutes with questions?
For everything.
2 minutes for everything. Do you guys want to do questions or a demo? Demo. Okay, cool. No, it seemed free.
Can you put me on? Hello. I can even give you a few more minutes, so we can even do a few minutes Q&A if you want to.
Oh, yeah, cool. Yeah, so I just booted into the Flipper Blackhat app. Sorry, I'm using like OBS to try to display myself. You guys probably can't see that, but you're basically seeing like a booting Linux system on the Flipper screen. When that's done, you get a little shell. So I can do, what should I do? Yeah, so I'm going to hit connect Wi-Fi WLAN 0. So that's going to go ahead and connect to the Wi-Fi here. I should be able to now test internet. So now you can see I'm pinging Google. This isn't working very well. Anyways, it's pinging Google. And then I can do evil portal start. And if you pull out your phone, you should see, yeah, I've never tested it with as many people before, but please don't enter anything like don't enter actual passwords or something crazy, but yeah, but if you pull out your phone and go to Wi-Fi, you should be able to connect to Flipper Wi-Fi. And I'm just wondering if this thing's gonna melt, because this is like 50 times the amount of, and it should then give you a captive portal, like you would see if you connected, and it should bring you to a screen where it says, I'm going to get hacked. And you... Anyways, I shouldn't be doing this. You guys can just do it. And then you enter your information, and then it will save that to the SD card. Did it work? Did anyone get it to work? Okay, sweet. Yeah. So anyways, that's all, and then maybe some questions, potentially?
We are a little bit over time, but the next talk still starts in about half an hour, so we do have a few minutes of a Q&A if you want to. Come up to the microphone, ask your questions. Do we have anything from the internet? Unfortunately not. So please, people, come up to the microphone, ask your questions. Any questions? Don't run. Come on, don't be shy, you can queue up as well. Come close to the microphone, please, to ask your question.
Hey, thank you for your talk. If I get your device, can I forego the new Hack 5 pager pineapple device that they just launched? Is this like a all-in-one solution?
So sorry, you're talking about the new Hack 5 pager device?
Yeah.
So I only saw that, like I just saw a quick video of it. I don't have I don't have much information on it, or don't know much about it. But eventually, this will be like a standalone device without the flipper. Because right now, the flipper is just like a battery and buttons. So.
Okay.
Sorry, did I answer your question? I couldn't quite.
Yeah, you did. Okay. Thank you so much.
Yeah, thank you.
Come close to the mic.
Yeah, you basically just answered my question. I want to know if it will be a standalone device at some point, because flippers are kind of expensive and hard to get, so.
Totally. So first off, you could use it as a I mean, there's a few different things that I could do. Like, I was thinking of making black pants. So you like put pants on the bottom of it, cool. And that would just like replace the flipper, and that would have like a screen and buttons. Or potentially, I mean, I think I'll probably do that because that's pretty straightforward. Like, I just need a battery charger, maybe an STM32. And then the other thing would be like rolling a whole new board with a keyboard, and like, I'm not sure, you guys saw the keyboard at the on the Y badge. So I know the guy that makes those, and the intention would be basically building a whole device with that keyboard and a screen and everything kind of ready to go.
Cool, thanks.
Yeah, thank you.
One more.
Mm-hmm. Hi, thanks for the very cool project. And what's your bill of material for that board?
The cost?
Yep.
So, yeah, it really depends, but I'd say roughly 40, 50 bucks, something like this.
Canadian or US?
No, euro. 40, 50 euro, yeah.
Mm-hmm.
Yeah.
Affordable.
Yeah, and then I sell them on my online shop, so you're welcome to pick one up or build your own. Yeah, so again, yeah, it's like 100 fully open source. Even all the tools made to use it were open source. So yeah, I don't know of anyone that's actually made their own yet, because it's definitely a challenging task with the double-sided components on both sides and BGA. So it's definitely not the best like learn to solder project. But yeah, yeah.
Well, if there are no further questions, and as we are over time by now, I think you will be around, right?
Yeah, I'll be around.
All right, then please give another very warm round of applause, Ryan.